From wherever you are around the world, welcome and thank you for joining us. Today we're going to be exploring where we came from. What is the Big Bang Theory? What's the origin of the universe? Who we have with us today is Dr. Kerry Welch, Professor of Philosophy at the California Institute of Integral Studies. Welcome to the Circle, Dr. Welch.
Thank you, Carlos.
Well, this is a fascinating topic. I always wonder where it came from. So let's figure out. Let's see if we can find out where everybody came from in one shot. Can you give us a little bit of insight of what is the Big Bang Theory?
Yeah, sure. So the Big Bang Theory kind of came about when these guys were pointing at a telescope out in space and they were having trouble getting rid of the noise interference. And they're like, maybe there are pigeons pooping on the satellite dish or something. Like, what's going on up there? And they went and cleaned it as clear as they could. And finally they figured out it wasn't an error in their instrumentation, but it was actually that space wasn't as cold as we thought it was. People thought, okay, well, if we look out into space, it's going to be perfectly cold in between all the stars and everything. And what they found was that there's actually about 2.3 degrees Kelvin of temperature. So 2.3 degrees above absolute zero, above zero molecular motion.
In space.
Yes. And so I like to call it the universal or cosmic blush. So there's a belying of past affections that happens when we look out into space and we see it's not perfectly cold. It actually has this slight bit of warmth to it. And what they extrapolated from that warmth was that the universe used to be much smaller, much hotter, and it has gradually been expanding and cooling. And from that temperature and from measuring how fast different quasars and such, how fast different objects are moving away from us, we can tell how fast the universe is expanding and extrapolate back from that. If everything is accelerating away from us, as it seems to be, then we know then we all must have been crunched into one tight little ball in the past, or at least to the best of our knowledge. So that's where the origin of the Big Bang Theory came from. We observe, for one, the cosmic blush, the background radiation, a slight temperature to the emptiness of space. And we also observe interstellar bodies moving away from us, accelerating. The further away from us in space they are, the faster they're moving away from us.
Let me ask you this question. I'll keep the analogy of the cosmic blush. Now, the way you measure the expanding universe is based off of light spectrums. Is that correct?
Yes. Yeah.
Is it the red part that shows that it's getting further away? I don't remember.
Exactly. And so if you look at the spectrum of light that comes from a star, you can actually see what elements that star is burning by the spectrum it produces. And so stars function on nucleosynthesis, and so they're squashing together. They're a balance between two forces, the force of gravity squashing things together in the middle, and then as they squash elements together, like they'll take a hydrogen and a hydrogen, the two lightest elements, and squash them together and make a helium and shoot off a photon. And so the light that's emitted from stars reveals to us what the composition of those stars are. What are they burning because of the signature of that photon? And we can also tell by the dust lines. So hydrogen has a very specific spectrum signature that we can see when we look at the light coming from stars. And we know, and it's basically the photons that are emitted as an electron drops from one orbit to another. It elects a photon of a very specific frequency. And so the spectrum of light is all of the frequencies of light coming towards us. So white light includes all of those frequencies.
Let me ask you this question, if I can.
Sure.
They use that for time measurement as well. Am I correct or am I off on that? Don't they use that to measure how old the universe is?
Well, I think probably what you're getting at there is that the further things are away from us, the older they are.
Okay.
We are actually looking back in time as we look out into space, because time takes a finite amount of time to get to us. It doesn't just instantaneously travel to us. So, for example, the sun, the light from the sun, takes 8 minutes to go from the sun to Earth.
So we're looking at the past sun.
Exactly. So we're looking at the sun as it was 8 minutes in the past. And so the further we look out into space, so if we're looking light years away, which is measured by the distance light can cover in 1 year, then we're looking that many light years into the past.
Wow.
That many years into the past. And so most stars are multiple light years away, and that's just even within the Milky Way galaxy. When we get beyond into other galaxies, we're talking hundreds of thousands of light years away. And so as we look out into space, the further things are away, the further back into the past we're looking. And so bringing it back around to that background radiation that we saw, that very slight temperature that is all over space surrounding us, we're immersed in this bath of the tiniest bit of warmth. We're looking, that is actually the Big Bang that we're immersed in.
And
The very ancient past co-present with us right now.
that makes it very hard for us to respond if something should happen to the sun.
Yes, we've got an 8-minute lag time.
It's not very good. Now, you were talking about galaxies. How many galaxies are out there approximately?
Oh, that's an excellent question. I don't know that I could answer that question. The best answer I could give is to say that when we put the Hubble Deep Field Telescope, or the Hubble telescope, up into space, we said, okay, well, we need to put a telescope outside of our atmosphere so we can get beyond all of that interference and get a clearer picture of what's out there. And one experiment they did was say, okay, we're going to point this telescope at the darkest area of space we can find, and we're going to leave the shutter open, I think it was for 10 days. And when they got that picture back, it was teeming with galaxies.
Teeming with galaxies?
Teeming with galaxies. If you look up the
Wow.
Hubble Deep Field, that will show you the picture that they came back with when they pointed the Hubble telescope at the darkest part of the sky.
Now, on this, okay, so we have an innumerable amount of galaxies, probably better said if I can speak. Can you tell me a little bit about the singularity? Is that the point you were talking about that we bursted out of?
Yeah, so there are actually two different kinds of mathematical singularities. One is the Big Bang singularity, and the other is a black hole singularity. And they're very similar, but there are mathematical distinctions between the two. And basically, a singularity is so general relativity told us that matter bends space-time. And so if you think about space-time as it's normally conceived as like a grid or something, that's out there. And if you think about it like the surface of a trampoline, and you put a big bowling ball in the middle of the trampoline, and everything sinks in and everything falls in towards that bowling ball. So that's kind of like the bend in space-time that maybe a massive planet or a star might make. Now, a black hole occurs when a star, as I said earlier, a star is this balance of forces, of gravitational force crushing in, and then the force of those photons that the crush is creating by smashing particles together and creating new elements. It's forcing photons out, so there's a force going out and a force going in. And when it runs out of fuel, if the star is big enough and it's burned the hydrogen into helium and made heavier and heavier elements in its core, but it's no longer big enough to fuse any of the heavy elements together anymore. The gravity wins, basically. When gravity wins and the star implodes, it no longer has enough outer force to balance that inward crushing force. That's what causes a black hole. So it's the implosion of a star. And it'll send off beautiful supernova remnants, shells of elements that we'll see in some of the pictures that the Hubble Space Telescope has taken. But that's what creates a black hole. If the star is big enough and it runs out of fuel and collapses on itself, it no longer creates just a dent in space-time, but more like a whirlpool. It pinches space-time off.
Wow.
And you get what's called the event horizon, where not even light can escape. So everything will fall into this black hole because of the density of matter creates such a strong gravitational field that it pulls everything around it into it.
And that's only at the event horizon, correct? It doesn't reach further out miles away.
Well, it does, because
it does.
It's a gravitational force, and the gravitational field does get weaker exponentially as it goes out. So it gets weaker and weaker the further it moves away, but it still has some pressure pulling in. It still has that gravitational force pulling things in. And so even the center of our Milky Way galaxy, we have evidence that there's a supermassive black hole in the center of our galaxy. It doesn't look like a black hole. It looks like a glowing orb, but because of all the stars that are being pulled in and that are coating the outside of that event horizon.
Hello, my name's Matt, and I'm an addict.
My mom was addicted to prescription pills when I was very young, before I even turned 1.
Are you or someone you know struggling with alcohol or drug addiction? Has everyone given up on you or your loved one? The caring staff at Elite Care understands and treats you as a whole person. We offer individual and group therapy, holistic healing such as yoga, nutrition, and spirituality, medication management, and PTSD treatment. By building upon your strengths and rebuilding broken bonds, we help you begin a successful life. With our staff of licensed psychotherapists and doctors, you can be assured of the highest level of care. Elite Care is the best option for long-term rehabilitation from drugs and alcohol. Contact 888-511-0607 for more information.
We know that the universe is expanding, which I guess technically means we're heading somewhere.
Yeah.
In a sense. Is it possible that the universe, let me see how I can frame this. Here we have the black hole. Here we are. The universe is expanding. Is it expanding because there's actually a black hole large enough sucking us in?
That's a great question, and I don't know that anybody has the answer. This is actually one of the theories that's been postulated that, okay, if there was such a singularity where all matter was in the, smaller than the tiniest head of a pin in the beginning and it exploded outwards in the Big Bang, then what's at the end of that? So one possibility is that it just expands out and freezes to death. Another possibility is that it hits a turnaround point. If there's enough gravity in the universe, then that gravity will once again overcome those expansive forces and start pulling everything back together again in what some people call the big crunch. And so that's one possibility for the evolution of the universe and where things might go. And it's dependent on that, the balance of energy and matter.
It's funny because I thought the show was going to talk more about where I came from, but now it's threatening my mortality, it sounds like. I don't know. We're going to explore a couple different areas with you here, if we may.
Sure.
Can you reconcile, I know there are debates in the Big Bang Theory, as you mentioned, 2 different main theories, but can you reconcile the Big Bang Theory with intelligent design, do you think?
Well, to me, intelligent design is looking at the evolution of the cosmos and saying that it is inconceivable. It was so impossible that gravity would have the exact forces that it does, and that water would form in the exact way it does, and that Earth would form at the exact right distance from the Earth, and that life would emerge, and all these very improbable, tiny little circumstances have to be just perfect in order for life to emerge. And so people say, therefore, there must be something brilliant behind this process, really encouraging it in the direction of life. And so that's kind of how I understand the intelligent design argument. And it really, and this is where cosmology hits up against philosophy, because it can't say, what is this intelligent force? We can call it God. We can say, oh, nature is just that smart. That's how it's going to happen. And another way to look at it actually is some more recent theories that have been coming out about the second law of thermodynamics. Basically says that all heat will cool off. All order will move towards disorder. But we find that within this tendency towards disorder, complexity arises, such as ourselves, such as life, such as consciousness. And so it's kind of difficult to reconcile these two ideas, because we know everything gets messy, things fall apart and break, and it takes energy to put them back together. But one way to look at this is that order actually creates disorder faster. And so within that second law of thermodynamics, which is one of the laws of physics that is you're not allowed to mess with. It basically is the arrow of time. It's the only law of physics that tells you that time goes in one direction. Every other law of physics is time symmetrical. It works equally well backwards and forwards in time. So the second law of thermodynamics is special to us because that's how we experience time, as moving in one direction. And so there's this link between subjectivity and this one law of physics that actually mirrors our subjective experience in that way. But at the same time, we seem to thwart it because we are this bizarrely complex organism that has arisen and seems to perpetuate order as much as it does disorder. And so the work of Ilya Prigogine showed that far from equilibrium, dissipative structures, and so basically that means organized structures dissipate heat faster than heat would dissipate by itself. And so in order for the second law of thermodynamics to do its job, to keep spreading heat out, it creates order in order to do that. One way to look at this is that nature abhors a gradient. So if you have something really hot and something really cold, the hot stuff is going to move into the cold stuff. It wants to be even. It wants to be at equilibrium. And it does this best by creating an organized structure. So if we use the example of water, because water flows, and so it's a nice metaphor for energy flow. And if we have water that wants to get from a full bathtub down an empty drain, it creates a whirlpool. So a whirlpool is not a thing, it's an organized structure of water. The water molecules are always changing. But it's an organized structure of water that moves the water from the fullness to the emptiness faster than it would move if it were not whirlpooling. And so if we think of ourselves as an organized flow of energy, a complex structure of energy that's actually moving energy from hot to cold faster than it could move without our ordered structure. And so in that sense, thermodynamics says, oh, things move from hot to cold, but it's a statistical law, so that's the bell curve in the middle. But there are still these little tails of the bell curve on the end, which is the order. And order is still moving things from hot to cold, but it's doing it in its own special way. And so I think that's some of what we're looking at. And it doesn't at all negate intelligent design. It just makes it that much more interesting. And that's where the philosophical part comes in. It's like, okay, we're this statistical anomaly, we feel like, because we look out into the universe and we may see that it's teeming with other galaxies, but we are not anywhere near close enough to know. We're just starting to discover planets that could possibly harbor life, that are orbiting stars at about the right distance and seem to have the right composition to have life emerge on them.
What do you think about that? Do you think we do?
What's that?
Do you think we do? There's a possibility of having life out there?
Absolutely. Absolutely. I mean, it arose here. It seems unlikely that this would be the only place, just because of the vast numbers that we're dealing with.
I hope if there's another Carlos out there, maybe he'll look like Antonio Banderas or something. Well, we got a couple minutes left, and I want to ask you the fastball question before we wrap up. This has been a great conversation. I almost termed this a head herder show. That usually means my head gets I get a headache during the show because it's such a complex topic.
It is.
But I stuck with you.
Awesome.
And we didn't get Tylenol today, so that's a good sign. You ready for your fastball question, Dr. Welch?
Let's do it.
All right. So you're a cosmologist as well. You study the universe. You study the planets and the stars. I had a theory, so I'm going to run it by you and see if you can say true, false, or, this is ridiculous. Astrology. We have astrological signs. People have certain personality characteristics associated with those signs. My theory is the moon causes tidal waves with energy. Okay, we got that energy pool. I don't know the terms as well as you do, so I can't really say it, but it does cause these tidal waves to go ebb and flow because of the energy it releases. Our brains are made of electricity and energy, electrical impulses. Maybe the moon, when we're born in a certain month, is at a certain energy wave or certain energy power or valence, and that kind of alters the personality of the human maybe a little bit. And then obviously nature and nurture affects the rest of it. So the question is astrology true?
That's a great question.
I'm long-winded, sorry.
And I personally do find that astrology carries a lot of truth. And of course, it's very personal and who's giving your interpretation and how much you take away from that. But I find that it's less of a causal system. So we're normally thinking of things in cause and effect. So like you were saying, the way the moon affects the Earth's tidal heights because of its gravitational interaction with the sun. And so that's a very distinct cause and effect relationship. And those are the same relationships that astrology uses, but astrology isn't necessarily cause and effect. It's more of a synchronistic system. And so just like a clock doesn't tell us that doesn't cause it to be 3 o'clock, it simply is an indication of a pattern of energy that we've set up. So astrology has been around for thousands and thousands and thousands of years in many different cultures. And so through those, years and years of observing the sky, they've come to associate different archetypes of the planets and their position in the sky and position with relationship to one another with certain energetic patterns that we experience on the Earth. So in more of a mirroring relationship than a causal relationship. So the idea is that it's kind of an as above, so below relationship, this mirroring. And that that you can go out into the woods. It's a synchronistic system, just like any divination system is a synchronistic system. So you can go out into the woods and you may be really drawn to this tree that's been burned and charred, but you may find a real beauty in that. And at the same time in your life, you may be experiencing a sense of loss or letting go of things that you need to let go of. And so there's this mirroring that can happen between anything external to us and our own internal experience that's often on an emotional level and a more subtle qualitative level. So the literal interpretation is very difficult, and it's not necessarily going to give you quantified specific things. Some astrologers do that, but the astrology that I tend to ascribe to is a little more nuanced. It opens fields of potentiality. It says this might be a really good time for this. This might be a really good time for that. You have this opportunity within which you can dance and weave and make of it what you like.
That's a great answer. You hit that ball out of the ballpark. Thank you so much again, Dr. Welch, for being on the show. We definitely got to bring you back. Thank you, everyone, for joining us as well. Remember, our motto is simple. Wherever there's psychology involved, even in the cosmos, we're there. See you next time, everyone.